Hello and welcome back. In the previous lesson, we minted our NFT on the Remix ID using OpenZappelin's smart contract library. But as I said earlier, this token is just a number which is saved in the smart contract. Where is the actual digital asset linked to this number? Well, in the working of NFT lesson, we have discussed that in order to connect this token with digital or real world asset, we have to add something called metadata to the smart contract. The metadata to the smart contract can be added using the base URI or the URI storage. Here in the ERC721 smart contract itself, you will find a function base URI which is internal and returns a string. So while developing our own token, we can override this function and return the base URI which we want. Now what this base URI does can be explained with the token URI function. Let's take a look at token URI function. As you can see, it saves the returned value from the base URI function in the local variable base URI and then returns the string. This is a conditional return value which says if the base URI string length is more than 0, which ultimately means if the base URI is declared, then return the next string, otherwise the empty string. Now this string over here is the URI pointing to the file containing the metadata in the JSON format, which we have already discussed. This abi.encodePack method will concat the strings base URI and token ID. Let's see this with an example. Suppose you have declared the base URI as https://drive.google.com and your token ID is 22, then the token URI will be https://drive.google.com/22. Now at this location, we should find the JSON file containing all the metadata of that particular NFT. I think you have got the base URI method. Now for all the tokens, this token URI will be automatically generated as per the token ID, but the base URI remains fixed. Now if all of your tokens metadata is not stored on the same location, then this method fails, right? So we can use the URI storage method. You can find this in the extensions and ERC721 URI storage solidity file. First of all, mind that this contract is extended with the ERC721 contract, so all the functions from that contract are now available in this contract. Here you can see we have the set token URI function, which takes the token ID and token URI as the arguments and saves it in the mapping declared as token URIs. The token URI function is also overridden because it's declared in the ERC721 contract already. Now along with the base URI logic, it also checks if we have token URI available and returns the URI according to the method we have chosen. Now for storing the digital asset and its metadata file, we can use any storage, let it be centralized or decentralized. Yes, we can use AWS Google Cloud also. But as our focus is more towards the decentralized system, IPFS is the right choice. IPFS or the Interplanetary File System is a protocol, hypermedia, and a file sharing peer-to-peer network for storing and sharing data in a distributed file system. And in upcoming lessons, we will also use the Revise network to store our metadata file. You can visit the IPFS and download the setup file according to your operating system. You can download a desktop version directly if you are not familiar with the CLI version of IPFS. Also, we don't have to look for the modules as we will upload the file directly. Now I have installed the IPFS desktop version and this opens like this. Here are 4 tabs. The first one shows the status. In order to access or upload the files, you should be always connected with the network. As IPFS works on peer-to-peer system, your node should be always connected to the network, otherwise your uploaded files will be delisted from the network. Once you are connected with the network, the status will be changed to connected to IPFS. And we have our details like peer ID and agent info. And below that, we have a graph showing the bandwidth over time and the network traffic. The second tab is Files tab. Here we can upload the files and get the files details like file CID and sharing URL. You can also import from the IPFS if you know the file CID. Now the next tabs are Explore, which lets us explore the file's Merkle forest, and the Peers tab, which gives us information about the peers like location, peer ID, connection, etc. And the last one is Settings to configure some parameters. For now we don't have to do anything. Our work is only related with the Files tab. So that's it for this lesson. In the next lesson, let's create one digital asset and its metadata file and mint the NFT along with the metadata and explore on the OpenSea. See you in the next lesson.